This is an example for sinusoidal modeling, and we are going to sketch, state its equation, and solve. On a merry-go-round, each horse moves up and down 5 times in one complete revolution of the ride, which takes 15 seconds. Each horse rises and falls a span, that means a range of 50 centimeters, and the horse is 100 centimeters high at its resting center position. So let's state our key properties based on the information given to us. Because we are talking about the position of the horse going up and down, your y-axis would represent height in centimeters, and your x-axis will represent time in seconds. We know that the horse is at 100 centimeters at its resting position. That makes our midline at 100 centimeters. So we're going to go ahead and write our 100 in the middle. Because the horse rises and falls a span of 50 centimeters, that means the range is 50 centimeters. And that makes our amplitude half of 50, that would be 25. So we will start from the center, we will go 25 up. So our max will be 125 and our min will be 75. One complete revolution of the ride is 15 seconds and the horse goes 5 times up and down. That makes the period 15 divided by 5, that would be 3 seconds. Sketch a graph of the height of the horse over time for one complete revolution. That means we are required to graph 5 cycles. Starting with the horse at the resting position and heading up. So I'm going to divide my x-axis into 5 parts. 1, 2, 3, 4, 5. And each of this part represents 3 seconds. So 3, 6, 9, 12, and 15. So this would represent one complete revolution. Now we're going to start sketching, starting at the midline. Now the horse comes back to this position at 3 seconds. Now because we are starting at the midline, it's going to be a sine curve. And the sine curve would have 3 points on the center line, 1 at max and 1 at min. So this would be our 1 cycle for this function. Now we're going to sketch this entire 15 seconds following the same pattern. We can determine the value of frequency, that would be k. So that is 2 pi divided by period. In this case, it's going to be 2 pi divided by 3. So k would be our frequency. Now, given this scenario, the equation to represent the height of the horse would be h at t equals, now this is going to be a sine curve or a sine equation because the graph starts at the midline. The equation would be h at t equals 25 sine k is 2 pi over 3 t. There is no phase shift because the graph starts at the y-axis plus 100. Part B for this question requires you to find the time when the horse reaches a height of 112 centimeters during the first 2 cycles. To determine the time, we're going to set our equation equal to 112. So 112 equals 25 sine 2 pi over 3t plus 100. To determine t, we're going to isolate and solve. Rearrange the equation for sine 2 pi over 3t. So let's get rid of the 100 and the 25. So 112 minus 100 divided by 25 equals sine theta. I'm just going to rewrite this value as theta. So we're going to solve for theta from here. So sine theta will be 12 over 25. Now because sine theta is positive, I know that this would fall in either quadrant 1, theta would be in quadrant 1, or quadrant 2. From sine theta equals 12 over 5, your alpha angle would be sine inverse of 12 over 25, and that would be 0.5. So in quadrant 1, theta will be equal to 0.5. Now theta was 2 pi over 3, t equals 0.5. We're going to solve for t by multiplying 0.5 by the reciprocal. So that's 3 over 2 pi. We're going to simplify, and this will be equal to 0.24. So that will be our first time when the height of the horse is at 112 centimeters. Now we're going to determine the second value from quadrant 2. In quadrant 2, theta will be pi minus 0.5. That would mean 2 pi over 3t equals pi minus 0.5. That would be 2.64. Now we're going to determine time by following the same steps. So 2.64 times reciprocal, that would be 3 over 2 pi. And that makes our second time equal to 1.26 seconds. Now if we go back to our sketch, we're going to approximate how many values we can see in the first 2 cycles. So if roughly we say this is 112 centimeters, so we see 1, 2, 3, and 4. So if we figure out T1, this would be T2, T3, and T4. So T1 and T2 have been calculated, and the values of T3 and T4 would repeat after 1 foot cycle. So I'm going to add a period. So I'm going to add 3 seconds, which is our period. So T3 would be 0.24 plus 3, and that would be 3.24. And T4 would be 1.26 plus 3, and that would be 4.26 seconds. So let's go ahead and confirm it from our graph. We can see that these values look very close or very accurate to our given values. The first one is 0.24 seconds. The second one is 1.26 seconds. The third one is 3.24 seconds. And the fourth one is 4.26 seconds. Therefore, during the first 2 cycles, the horse will be at 112 centimeters at 0.24 seconds, 1.26 seconds, 3.24 seconds, and 4.26 seconds.